Well, good morning. This is the second part of Rational Functions video that I started a few minutes ago, but I got interrupted because it was Zoom time. So we're going to pick it up right here and finish this up. Let's take a look at transforming reciprocal function, transforming the reciprocal function, your parent 1 over x, okay? So let's take a look at this. Say it's g of x equals 2 over x plus 3. So how about if we think of that as 2 times 1 over x plus 3, okay? So if you think about your transformations, the plus 3 down here, we're going to have a left 3, and up here we've got a vertical stretch of 2. Okay, so if you think about a little sketch, we're going to go over here to the left 3. Okay, and it's a reciprocal function, so we know the parent looks something like this. Okay, kind of ran it off the side of the board, but I think you get the idea. All right, so let's take a quick look at a couple limit statements. Let's say we want the limit as x goes to -3 from the left, and then we want to know the limit as x goes to -3 from the right. Okay, so if you look at those two things, so here's our -3 right here. So from the left, that's what that little mark is there, left hand coming towards that vertical asymptote, what's your graph going to do? It is going down to -infinity. Okay, if you're coming from the right, so here's my right hand and I'm coming towards this asymptote, my graph is going up. So from the right, I am going to positive infinity, okay? So what does that mean? Well, that confirms that we do in fact have a vertical asymptote at x equals -3, okay? The other part is to take a look, what about HA? Is there a horizontal asymptote? So to check for HA, we're going to take the limit as x goes to -infinity, and the limit as x goes to positive infinity. Okay, so we're looking clear out at the very ends to see what's going on here. Okay, so the -infinity. So as I'm coming across this way, back off the video, our graph is approaching, you're right, 0. Okay, as you're going out here to the right, graph comes down, 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 never going to hit that x-axis down through here. So again, it's approaching 0, okay? So in the previous video, I called that B, okay? So this is going to tell us that our HA is actually y equals 0, and that's going to confirm that for us, okay? All right, let's look at one more example. All right, give me a second. Need a bigger board with a moving camera. So let's try this. H of x equals 3x minus 7 all over x minus 2. Okay? So this one looks kind of messy. So we've got to have a way to handle it. So something that we could do, in fact, I'll go this way. Let's take 3x minus 7 and divide it by x minus 2. Okay, so if we do our little long division here, we'll put 3 here because you've got 3x over x gives us 3. So we'll multiply back, so 3x minus 6, draw your line, change both signs, so we have a remainder of -1, okay? So our function now looks like this, 3 minus 1 over x minus 2. So 3 is your quotient, remainder over divisor, okay, that's what we've got. All right, so what in the world does this thing mean? Well, from down here, we know it's going to be to the right 2. The negative says we want to reflect across the x-axis, and this 3 out here is an up 3, okay? So if we took a look here, we'll do a quick sketch. We're going to go, what did I say? Up 3 we've got right 2. So that's our 2, and here's a 3. Okay, and then it said to reflect that parent function, that reciprocal function. So we're going to have some graphing going on up here, and then again down here. Okay, so then if we look at our limit statements to see if we can confirm what we think we know, for VA, let's do the limit as x approaches. Okay, what do you think is the VA? If you said 2, okay, from the left for h of x, and then you're going to do the limit as x approaches 2 from the right of h of x. Okay, so if I'm coming from the left, I'm over here, left, I'm coming across, where's the graph going? Up to infinity. From the right, okay, I'm over here to the right, I'm approaching that horizontal here, or I'm sorry, the vertical asymptote, coming across here, what's happening? The graph's going down to negative infinity. Okay, so remember, if our answers are plus minus infinity, that confirms a VA. So VA is definitely x equals 2. All right, so the other part is to check the end behaviors. Okay, we're looking for a horizontal asymptote, so we're checking for HA. So we do the limit as x goes to negative infinity, so to the left, what's happening out there for h of x, and the limit as x goes to positive infinity of h of x. Okay, well, as you're going to the left, this way, this graph is coming down, 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 approaching 3. Okay, as you're coming back this way towards me to positive infinity, again, the graph is approaching 3. Okay, so that value right there tells me y equals 3 is in fact our HA. Okay, so in behaviors, talking about HA, we've got our vertical asymptotes are confirmed, and I'm going to stop this video here, and I'll start in with another one for the next part for rationals. Thank you for watching.